Okay, so this is objective 6.4a. We're getting ready to amp up. These are not the basics of logarithms. These are more complex tasks that we're going to be performing. Today's topic is expanding and condensing logarithms. And your instructional objective, you will be successful when you can use the properties of logarithms to condense and expand them in preparation for solving more complex equations. Also, you will be using your exponent rules often, and so if you're a little rusty, we're going with your exponent rules. We'll have to clean that up, get the oxidation gone. So here we go. Log properties that we often use when we are condensing or expanding logarithms. Property 5, which we've already talked about, but we're going to actually use it today. Property 5 in condensed form says this. Now remember these things. When b, m, and n are positive numbers, and b does not equal 1. So that's still, when we're working, those are the rules for our logarithm. So if we have log base b of m times n, so that's basically a condensed logarithm. There's two arguments here, m and n, but they're being combined. If I want to expand that out, I'm going to do the log base b of m plus the log base b of n. And this is considered the product to the sum. And it can go either way, which is why I made the arrow double-sided. Sometimes you get the equation in expanded form and you want to condense. Okay, it goes hand in hand with this exponent rule that says if I have an exponent or a base raised to the exponent x and I multiply it times the same base raised to an exponent y, in expanded form, that's two bases. I can condense it into one base by doing what with my exponents? Adding them. So dusting off those rusty exponents. That's not so rusty. You guys, we use that one pretty often. Okay, so those go hand in hand, those two. Because I just really, really hope that you're starting to get to this, that a log is actually replacing an exponent. It is an exponent. So it's this. It's this. It's that. It's that. That's what a log is. We're doing math with exponents. Okay. Here's property 6 that says this. The log base b of m over n is equivalent to, in expanded form, the log base b of m minus the log base b of n. And that's the quotient to difference application of a log property. Now, what do you think it's related to if I was talking about exponents? Well, here I did product to sum. So now I'm doing what? Quotient to subtraction. So that would be b to the x over b to the y. You're right. Equals, condense it to one base, b to the x minus y. Absolutely. And really what you're saying here is then when I bring this y up to this x, I'm going to change its sign. It becomes a negative exponent, so I have to subtract it. It's pretty much the shortcut to that. All right. Then here's one more. 7. Log property 7 says this. If I have a log base b of m to a power p, that's a power. Remember that log base b of m is actually an exponent. It's already a power. And I'm raising that power to another power. So it's power to power. It's the same as the power times the log which is just another power. So this is power to product. And again, you can go back and forth between those two properties. And if I were to connect that to its exponential buddy, this would be the base raised to the x raised to the y, raising the x to the y, is the same as the base raised to the x times y. It's just power raising the x to the power of y, multiplying the powers. Okay, so they're really connected. There's two other exponent rules that I do want to address. The first one is this one. If I have the y root of b to the x power, and I want to write that as a condensed base to a power, that's base to the x over y. Remember that the power on the base is your numerator, and the root is your denominator. Well, the index of the root is your denominator. Okay, so that's one thing that you have to remember. You have to be able to go back and forth between those two. Okay, so this is the expanded form. This is the condensed form. Okay, and then the other one is this one. 1 over b to the x. If I just want to write that base b, it's to the negative x, and that's your negative exponent rule. If you're going to take a base across a fraction bar, you have to change its exponent to a negative exponent. Okay, so we will be using these two properties often. We will use these properties as well, all 5 of them, usually when we're simplifying things. Okay, so like I mentioned, I will be doing this very methodically. So I'm going to color code, and then if you are already experienced with this, of course, you can go straight to whichever's the answer if you can see it. I'm color coding thusly. Step 1. Let me read the instructions. It says use the properties of logarithms to express in terms of logarithms of x, y, z, and w. So I want you to expand it out from a single condensed log to multiple logs of each with its own variable. So step 1, I am going to suggest that you rewrite the log as a product by, what was the word? Applying the negative exponent rule and the power, no, not power, root to power. Root to power rule. So when I say that, I'm talking about this rule right here. Changing this root to a rational exponent, a rational power. Okay. All right. And then after we do that, step 2, we are going to, in blue, I'll do that in blue. We are going to apply property 5 and expand to the sum of logs, because we'll write it as a product, and then we'll expand it to separate all of your variables into their own logs. Last step. In green, we're going to apply property 7 and power down. So we're going to change it from a power to a product, basically. But I think power down just really gives you a direction. So let's take a look at this first problem. Let me move my little guy out of the way here. Let's take a look at this. Come on, get out of the way. All right, so I'm going to pick up my red pen. I'm going to look at my problem here. So here I have the log of a product, x times z. And it doesn't have any negative x. It's not a quotient. There's no changing of roots to powers. So I can skip step 1 and go straight to step 2. It's already the log of a product. So I'm going to apply product 5 and expand to the sum of log base 4 of x plus the log base 4 of z. So they're their very own logs. And then step 3 is to power down. But both of these logs are being raised to the first power, so there's no reason to bring that x to the first, bring the 1 down. There's no reason to do that. So that's done. That one was very basic. Okay, here's the next one. So here we have a product and a quotient. Multiplying w times y, dividing by x. I say let's rewrite this as a product by taking this x that's in the denominator, bringing it up and changing its exponent from a positive 1 to a negative 1. So we have the log of a product. Okay, and then grabbing my blue pen now, I can go ahead and expand that out as a sum of log base 4 of w plus log base 4 of y plus log base 4 of x to the negative 1. And then step 3, power down. So I don't need to bring any powers down there, but here I'm going to power down that negative 1. So final answer, log base 4 of w plus log base 4 of y minus log base 4 of x. Now you may have seen directly from step 1 to step 3, and that's okay. If you've done this already before, you probably do that. But remember what I said, I'm doing this for people that have never done this before, so they can follow the same set of steps until they're comfortable. Questions? Okay, let's go to C then. So C is already the log of a product, but here we have a problem because we have a root. We need to convert this to a power. Okay, I don't need to convert this to a power. It's already to a negative 2, but let's convert this. So I would rewrite this as x to the what? 7/4 y to the negative 2. And that's a 4, not a y. Okay, so I'm just going to rewrite that and remove the seventh root, or the 4th root, excuse me. Now I can write it out as a sum because we've written it as a product and we've released the 7 and taken the power. So log base 4 of x to the 7/4 plus log base 4 of y to the negative 2. And then switching to our last color, let's power down and completely expand these to their most expanded form, 7/4 log base 4 of x minus 2 log base 4 of y. I'm going to put boxes around my answers so that they're separate. Questions about that? Okay, so you try D on your own. Press pause, try it on your own, come back to the video, see if you got it right. And so you should have gotten the answer 3 log base A of x plus log base A of w minus 2 log base A of y minus 4 log base A of z. Any questions there? Yes.
Shouldn't it be plus 4 log A of z because the y squared and z to the 4th are being multiplied down?
But they're in the denominator, so they represent negative exponents. So in step 1, here's the thing. I hear what you're saying. So in the denominator, you have y squared z to the 4th. and it's a product. So, but what you're doing is subtracting it because it's in the denominator. So when you separate, you still have to distribute that negative to both of them, which is why I think it's probably just better to convert it originally to a product and apply the negative exponent rule so that you can see the negative exponents. Okay, last one is this one here. Now I'm wondering if we can go straight from the beginning to the end. Probably we can, but I am going to continue. How could I replace z cubed root? Z to the 1/3, right? And how about x? If I want to write it as a product, I got to bring it up, so x to the what? If I'm bringing it from the denominator up to the -1, and how about the y? If I'm bringing it up, it's y to the negative half? Yeah, because it's a square root. It's y to the first square root. So I'm going to rewrite it as a product. So I'm just redoing that and rewriting it as a product and putting all those negative exponents in. Okay, now we'll expand it. Since it's a product, we can expand using product to sum. So the log of z to the 1/3 plus the log of x to the -1 plus the log of y to the -1/2, and then switch colors and power down, and you're done. And you can see what's happening there. So 1/3 log of z minus log of x minus half log of y. And so those are strategies if you're going to expand a condensed logarithm. Now we're going to do the other thing. So we're going from using the properties to write the expression as a single logarithm. So we're condensing. So we're going from expansion to condensation. So what we want to do is reverse everything we've done. So the first thing we're going to do, and the other thing, the last thing we did was power down. So on this one, the first thing we're going to do is reverse that, which is what? What's the reverse of that?
Log 3xy.
Step 1. Why can't I write in green? Oh, because I picked white here. Let me pick green. Number 1, power up. We're reversing everything. So again, we're applying property 7, but we're going to power up any powers. Then step 2, we had apply the product to sum. Here, step 2, we're going to condense to a product. From a sum to a product. That says produce. How about product? There we go. And then step 3 is we're going to change the negative exponents back to positive exponents and the rational exponents back to power or roots. Okay? So negative exponents to positive exponents, and then rational exponents to roots. And that completely undoes the process that we just practiced. So let's take a look at problem number 1. So when I look at problem number 1, and I'm starting with my green pen here, power up. Well, the power that's here is a 1, and the power that's here is a 1. So if I power that up, it's not going to do anything. So that would be silly for me to do that. Step 2, because it's already a sum, I can go ahead and condense it to the log base 3 of x times y and put the logs back together as a single log. And then since I don't have any negative exponents or any rational exponents, I'm done. It's finished, condensed. This is the process that you guys will be using often. Your problems will not often look like D or E. We're going to practice them though. Okay, part B. So picking up your green pen again, I do want to power up this one. This is a -1. So watch me. When I power that up, I'm going to change it to addition. So now it's going to be a product, not a quotient. Okay, so I'm powering up that negative, changing it to addition, and now I can condense it to the log base 3 of 2z x to the negative 1, and then switch, and let's deal with this x to the negative 1. We don't want a negative power, so log base 3 of 2z over x. Done. Next problem. One more together and then one apart. Here we go. We're going to power up the 5, power up the negative 1/3 and change it to addition, and then switch to blue. And since it's a sum, we're going to condense it to a product of 1 log. So the log base 3 of y to the 5th z to the negative 1/3. And then let's evaluate the z to the negative 1/3. Not only is it negative, it's rational. So it's got to go to the denominator and change to a cubed root. So it looks like this, log base 3 of y to the 5th over the cubed root of z to the first power. You don't need to put a first power on that. Do you have questions? Okay, you do the next one. Press pause, come back to the video, see if you got it right. So you should have gotten the answer. Log base a of x cubed root of x minus 2 over quantity 2x plus 3 to the 5th. Okay, so there's that one. Now this last one is more complicated because it has a lot of simplification that's really necessary if you're going to get the proper condensed form of this logarithm. And so some things that I want to talk to you about here. First, we'll go ahead and power up. So I'm going to power up that 1/3. But notice that I'm raising a product to a power. So in the intermediate step here, I am going to be distributing that 1/3 to both of those. And I can do that. Hear me, hear the words coming out of my mouth and understand them. I can go power over a product. You'll notice that I didn't do this over here. I didn't do 1/3 x to the 1/3 minus 2 to the 1/3 because I can't do a power over subtraction or over addition, but I can do powers over products, over multiplication. I can also do them over quotients. So I just want to clear that up because I've noticed a couple people today as the day's gone along being really confused about when you can do that and when you can't. We'll power up that negative 5. And P.S. I will be distributing that to both of those in the intermediate step. So let me write this as a condensed log now, a natural log of y cubed x y squared, because I'm doing x cubed times 1/3, which is x to the first, and y to the 6th times 1/3, which is y squared. And I'm also evaluating this here. This is x to the negative 5 over y to the negative 5. And I'm going to deal with that as well. And here's the other thing I want you to do. Just go ahead and put that y is in the denominator. All of those other terms are in the numerator. Okay, and it's true. You can just put a 1 under them if you don't believe me. It's true. They are in the numerator. Okay, so now what I need to do is simplify this as much as I possibly can. So the first thing I would do is I would evaluate and I would flip the xy, put the y in the numerator, put the x in the denominator. Are you okay with that? Yeah. So we will have the natural log, I want red, the natural log of, okay, I'll wait until the end to combine everything. Xy squared, y to the 5th, all over x to the 5th. I'm just evaluating that negative exponent rule. And now I'm going to apply quotient product rules for exponents. So in my numerator, how many y's do I have? Imagine. 3, 4, 5. How many? So the natural log of y to the 10th over, and I have 1x in the numerator and 5 of them in the denominator. So how many do I have left in the denominator? 4. So basically, if you're wondering what I did, I'm just imagining expanding that out, y cubed, y squared, y to the 5th times x over x to the 5th, and then canceling out their common x and simplifying that down. Okay, so sometimes your problem will start out, I do not know why this keeps moving. Let me get it out of the way. It starts out looking really complicated, but when you condense it, it's not. So just be aware of that. So again, we are doing problems 2 through 16 even on your assignment. And if you need to retake quizzes, we can do that right now as well.